Hello, everybody, and welcome to the October 4th, 2022 iteration of the Kubernetes SIG-Windows community meeting. As always, these meetings are recorded and uploaded to YouTube, so be sure to adhere to the CNCF Code of Conduct. Let's get started. For announcements, just another update that enhancement freeze is this Thursday. I believe it is 6 p.m. PDT. So there's that. I think that for most of the enhancements, we're in pretty good shape. I do need to get some reviews on the host network support for Windows kept, though. Does anybody have anything else they'd like to announce? All right, if not, we can see if there's anybody, any new contributors here that would want to introduce themselves. We can give some space to have anybody who's new here to either introduce themselves, say what they're working on, what they'd like to get out of the meetings. If they'd like, feel free to just unmute yourself or raise your hand. All right, I don't see anybody who'd like to do that. So I think we can get on to the agenda. James, looks like you're first up. Did you want to share your screen?
Yeah, we can go through everybody else's first and then do this at the end, I think.
Yeah, let's see. I just see a question about testing and UDS with host process pods. Does anybody know who posted that? I did see something in Slack, I think yesterday. I didn't have a chance to respond to it yet, though, about this. Let me see if there's a link. It looks like it's Alex Ding who's saying, I'll link to the Slack chat, that there's a question here. I'll follow up on Slack about this after the meeting, since Alex isn't here. But basically, the guidance is just to not use volume mounts to mount in the sockets. Just whatever whatever path you need when you're running in a host process container, just use it. Hopefully, and make it unique somehow for the container, and then it should just work. We've got a lot of unit tests or EDE tests that are validating this for both named pipe and Unix domain sockets. So I'll follow up. Next is I just see a link to a Q proxy regression in V124. Does anybody know who added this?
Yeah, I added that.
Okay, let's open that up and see. Do you want to talk to this, David?
Yeah, there was a regression in 1.24 and above found. It causes stale HNS load balancer proxy rules. Time a pod is deleted. Each deletion will kind of leak a external VIB load balancing rule, which references kind of endpoints which no longer exist that were deleted, or any pods that were updated that belong to a service. So yeah, I mean, there's a fix out for this. And yeah, I guess we just have to get that fix in. And yeah, or review it. Any comments? Leave any comments there.
Okay, and it looks like this is impacting all versions 124 and above.
Yeah, I think so. Yeah, I think the in the issue there's like a link I add. So this commit is where I mean we've singled it down to this commit, and there's like a one line there which I think was perhaps a typo, or it's like I think there was a. I remember like Sravan mentioning that this might have been like someone accepted like a merge conflict that kind of went wrong there. But yeah, there seems like there's some duplicated line there, so that is causing the issues, the leakages.
Okay. sneaky.
This was where was this when we fixed that other load balancing thing that was happening? A while back, there was an external load balancer issue.
There's a
Where
health
node-
check. Yeah.
And is it like what? Because it's not like we're merging stuff to the Windows kernel proxy all the time. So that must have been the PR that
Yeah.
broke it, right?
Yeah, that's the PR fix health check from Google's load balancer.
Yeah, for the Google one, right?
Yeah, something seems like, I think it's just that one line. I don't think the rest of I don't see any other issues like after I removed this line.
Yeah.
But you can see it's like right after, can you go back to that line, Mark?
Mhm.
You can see like right after the else above it, skipped creating HNS load you
I
can
just expanded that a little bit.
you can,
more.
yeah, can remove the expansion actually. I think it was visible. Yeah, or it's fine, yeah. And the else, like line 1320 is like skipped creating HNS load balancer. And then right after that, we actually do the operation that we
Okay.
just skipped. So that's,
And it looks like here's where the line is duplicated.
yeah, that one is good. The one that's after that is the
Yeah,
problem.
yeah.
This one,
But
yeah,
it could have just been a refactor or something.
yeah,
and then
yeah,
Diff got confused.
yeah. So yeah, the fix is just to remove those two lines. Then I
Okay.
didn't see any issues after that.
Okay. Well, yeah, and you said there's already a PR for this open?
Yeah, I raised, yeah, and they're linked, the issue.
Okay, good. Well, I guess try and get that in soon and get this backported.
Yeah, I don't know if we should make like a documentation or like keep an issue open. This is, I mean, this is gonna impact like everyone on 124 and above until the fix is released.
Yeah, let me see if we can. I'm not sure how we would want to advertise that. But I'll see if I can figure a good thing out.
Could you also highlight on how this would manifest itself?
Yeah, actually, can you scroll up to the issue description? So, what you will see is there'll be, we have a script that lets you detect this issue that I linked, linked in the issue, this network health.ps1. If you're suffering from this issue, you can just run network health.ps1. I'll give you the command. I'll actually add that to the exact command, but it will print, that you have one stale VIP, and you can inspect it with the PowerShell that is also in the issue. If you don't want to use the network health.ps1, you can view the policy lists, search for the VIP, and you'll
So
see
is
there's
the
multiple entries for that VIP. So there's a duplicated load balancers basically.
So is the
I see.
issue that then you have, if I allocate, because if you're having multiple, is it if I allocate all of my entire cluster IP range, then at some point I'm going to have cluster IPs on certain nodes that are zombie IPs that can't be reallocated on those nodes? Like
Yeah,
how would you see this if you were a user? You would
you'll see
certain
this.
IPs would stop being routable at some point.
You'll see this because you'll try to connect to your VIP, and it will load balance to something that no longer exists. So you'll see like just traffic failures. So it might want to match a rule. It'll match a rule that's stale, that's referencing endpoints that no longer exist. So it'll try to redirect the traffic to those endpoints, which obviously no longer exist. So you'll see the traffic just being dropped. It'll try to.
But to see this, you would have to create a service with a given IP and then delete that same service and then recreate that exact same service again later, right? With the same IP.
you can just delete a pod, any modification to the service itself. Let's say the endpoints change because a pod got added or deleted, like you're scaling down or up your service. Then now we're recreating that service. Kind of kubeproxy will recreate that service policy, and it will leak because of this bug. It will leak the previous one. It won't clean it up.
Mhm.
Now you'll have
Okay.
two load balancing rules that will like it'll anytime I see this VIP, that service still exists, right? You just scaled it up or down, but you'll have two duplicated rules now. And one of them will reference an endpoint that no longer exists, or like one that has been removed. And so if it matches that rule, then some of the traffic, I mean, some of it will pass because the other endpoints will still be valid. But if it decides to load balance to the endpoint that got deleted,
Yeah, it makes
traffic
sense. Okay.
drops.
Got it. Okay. All right. And this is only for service type load balancer. Yeah.
Yeah, I think it might be on others as well. I haven't tested that. That's just the repro steps. I think it might be other service types as well. I haven't tested that, to be honest.
If there's other service types, then we could very easily build like a cheap end-to-end test that we could run to catch this later. Okay. Cool.
Yeah.
Okay. Thanks for finding all of this, David.
Yeah.
Okay. Yeah, maybe we should start. Would you mind, David, posting on the SIG-Windows channel and maybe mention it so that people can get in Slack? That might be a good way to first start letting people know. We can just link to this issue.
Sure. Yeah, I can do that. Yeah.
Okay. And then, yeah, well, I guess just try and get this spec ported as soon as possible.
Yeah, sounds good.
Cool. Any other questions about this? Or anything else to add, David?
No, I think that's all I have to add. Oh, one more, or actually one last thing. Actually, if you can make it so that your service, all the pods that belong to the service are only on one node, then this issue, I don't see the connectivity issues, the connectivity failures. I don't know. I have some workaround steps listed there. That's kind of one possible workaround. That's just what I've seen, but
Okay.
yeah.
I guess we can keep the issue updated if we find more.
Yeah. That's all I have.
Okay, bummer, but thanks for finding that. That's a good catch. Cool. Does anybody have anything else they'd like to discuss? Or James, would you like to do a demo?
Sure. There's nothing else.
Oh, I think I see Alex joined the call. And I believe, Alex, you asked this question about testing UDS, Unix domain sockets, correct?
Yeah, sorry. I thought the demo could go first, but yeah, if you have a little time. I just wanted to ask a few questions about the whole post-process pod and how exactly it works. So you mount, like the host process is restricted to some like randomly generated mount path, right? And
so the behavior is changing with Containerd 1.7, and that's when we're aligning with taking that feature to stable. So there's two kind of behaviors for how we set up mount points. One is implemented in Containerd 1.6, and one is in Containerd 1.7. That's all. We go into some detail into that in the KEP, and the reason why we're changing that. But it will be slightly different. Once we switch to Containerd 1.7, volume mounts will work much more like they're actually like regular containers, where if you tell it to mount something at like /var run foo, it'll show up at C:var run foo instead of at that special location, because we're changing the types of the ways that we're doing the file system setup.
I see. Yeah. So yeah, because with 1.6 it was a little confusing. I believe that's the one I'm playing with right now. Like you have to actually explicitly state the full path, right? In order to access anything, even when you're in the container environment. Yeah. So that breaks some integration tests because I think they had absolute path setup.
And there is an environment variable that we set on in each container that points to that. That's also in the documentation and in the KEP.
Right.
But it's possible that code that's checking for if it's an absolute path is not understanding that environment variable will be kind of rooted at an absolute path.
Yeah. So I mean, I think we might have to. So the only way to do it right now is to change our test to like kind of prepend that the mount path to whatever path like test directory we're using. But then later on, that's going to change. Is there like a timeline on this?
So
if we make the changes right now, it might be.
The timeline for how it's changing is all of the code is already in the containerd 1.7 or like in containerd main branch. So because it's it will be a breaking change, but what we're doing to mitigate the breaking change is if you are running containerd 1.6, you will always get the current behavior. If you're running containerd 1.7, you'll get the new behavior, but then we'll also symlink we've set up some backwards compatibility, which is also described in the KEP, so that if you are using that environment variable to find the volume mounts, you'll be able to find it without changing your workload container.
Okay, yeah, that sounds great. Could you like just send me the KEP offline and I can take
I'll reply to your Slack, your post in Slack. I saw that yesterday. I didn't have a chance to respond yet.
All right, thanks so much.
We can do that. Okay, cool. Yeah, we could continue that conversation in Slack with some more details then. So. All right, James, I'm going to stop sharing so you can share now.
Okay, can you hear me?
Yep.
All right. Just get the right screen here. So a couple weeks ago, there was like a little mini hackathon so you could go explore and experiment with things. And the thing that's been on my list for a very long time was checking out the eBPF for Windows project. And so I'm just going to show off kind of where I got and share the learnings I had. It didn't get very far, but I do have a kind of working program and thought I'd be able to maybe accelerate other people that are interested in it. And some folks expressed interest in it last week as well. So for those who don't know anything about this, BPF is Berkeley Packet Filter, I believe. I don't think it's related to that anymore, but it's a Linux technology that's built into the Linux kernel, and Windows is adopting the technology for the Windows platform. And so there's a project up here. There's a team that's working on this. You can actually join their meetings on Monday mornings if you're interested in learning more or just joining the community. So what they're doing is trying to bring the similar process that you have for eBPF on Linux to Windows. And so my idea was to try to create an eBPF program for qproxy for the KPNG, the qproxy next gen. There's a Linux version of this out there. That's kind of a demo to show how this maybe would work. And I wanted to see if I could get it for Windows. I didn't get quite that far yet, but still working on it. So there's this diagram here is very complicated, but I think the important part of eBPF is there's two different parts to it. There's a user program, so like a user space program. So the program that you kind of write in maybe Go or C++ or something that's running in user space. And then there's another program that you write typically in C and then load into the kernel. In Windows, what happens is that gets translated into a driver, and it runs as a kernel driver. And then the user space application talks to the Linux, the kernel space application through what they call maps. They're basically key value stores for storing information in memory. And so if the demo I'm going to show is if I wanted to block a particular IP address, I would write that IP address into a map. The eBPF program running in the kernel would look at that, identify that there was a connection made to a particular IP address, and then shut down the connection right there. So that's what I'll demonstrate here. You can learn a lot through the website here. This tutorial kind of talks about eBPF and what the program looks like and how to interact with it on Windows. I recently just pushed updates to this, so it should be a lot easier and smoother experience if you're trying to get started with it than what I had. Okay, so I'll show you the example. So down here, what I can do is I'm just going to curl this IP address. This is the HTTP bin website. So I'm just calling there. I'm getting a 200 back. And what I can do over here is run my eBPF program. So I wrote a little Go program. That's my user space program. It's going to take the eBPF program and inject it into the kernel, and then tell the program to block any IP addresses that go to 18.207 and just completely reject them. So hit go run. It takes a minute to compile. I'll talk through what some of this stuff does, but I am essentially, I mentioned those maps. I injected the map with this IP address 18.207, which you'll see is the same over here. The result means that it was successful. And if I've got a little trace program that sets up some ETW traces so we can see what's actually happening inside the eBPF program. And so it just set those up. And now if I try to make that request again, I get rejected from the request. And we'll see, we saw the connection, it's going, and then it's being blocked. I haven't quite figured out how to do the ports yet, but it's blocking that IP address. I guess it made 2 requests. I don't know if that's like curl stuff, but if we were to take this and there's a little program online, converts decimal to IP address, we should see, oh, it's not the right one. Connection to let's try that again. See if nope. One of those. Let's see. Okay, it blocked 9624. So I should see this should be converted to 18, but I don't know why it's coming up wrong. I might have. I was playing around. I was trying to get the redirect working this morning, and I might have messed up the outputs. But you can see that we are actually blocking something. And if I were to unload the program and run it over here, I'm now able to connect again. And so that's kind of like a really simple demo. The idea is that I would be able to read from the API server, take those IP addresses, the VIP IP addresses, say if a request comes to this VIP, I can redirect it to these backend IP addresses for the pods. And that's what I'm trying to work on. There's a current PR that actually implements that in the Windows eBPF. Right now, the redirecting doesn't work. And so I've built from source, and I'm playing around with like how to get that actually set up, and haven't quite got there. So from a code perspective, I'll just kind of walk you through what I'm doing. It's really simple. but it took me a little bit to like figure out how all this kind of interacts and works together. So this is my user space program. I'm just taking a couple IP addresses, and this is my program that I'm going to load. This is the eBPF program, and I'll talk through that in a second. Basically, you grab the eBPF program. It's built into an ELF file, and you take it. You get the object. You load it into the system, and then you need to attach it to. eBPF has these attach points, so there's a set of attach points that are implemented in the Linux kernel, and then there's a subset that's implemented in Windows. So you need to attach it to that attach point for it to actually run. And I was actually, when I was testing this earlier, I was having a really hard time figuring it out. It was because I was forgetting to attach it. And then I go get the map that they're going to interact with. And finally, I create a little object here, and then pass it down and update the map. So and you have to. This is all using SIG-Go. So behind the scenes, I'm using all unsigned integers and then unsafe pointers and passing that down to the map. The map updates, and then it comes back and says you're good to go. So the eBPF program is usually just written in C, usually in a separate folder from what I can see. And then here's the map. So I'm saying this is my structure that I'm working with. And here's the size of it. Here's how many entries we can put into it. You can put much more than 100. And then down here, this is where we define the attach point. And this function can be anything you want. It comes in with this structure that says like, here's who's calling, how they're calling, a bunch of information around what they're doing. And then I just pass the map and that information to this function. The function goes through, I do a lookup into that map that I filled from the user space program. If it's not in there, I'm saying there's no rule, you can go ahead and proceed. This is the part that I'm still working on. Otherwise, I'm blocking, and I just return a reject, and that's how it shuts down before it ever goes any further in the system. To build those programs, I have this like Gen eBPF. You need the NuGet package, which has a bunch of like include files, and then you use Clang, and you compile the C program into the ELF file, and then I'm just running a verification. Something I didn't mention before is that these programs have very strict guidelines on what you can do in there. And if you don't do certain checks for lengths of the maps you're working with, you can't load that program. And so I'm just running a verification to make sure that my program passes that verification. And that's kind of a very quick overview, but like if you don't have this check for like null, then your program won't pass verification. You can't even build it, and you can't load it, and it won't run. So that's pretty much everything. Any questions?
So could we one day have like say a shared implementation of let's say a backend in kubeproxy or KPNG, like one shared code base that uses the same C code kind of for the redirect across Linux and Windows?
That's a good question. So there is like a BPF program that was put into KPNG that uses this C group connect. I tried compiling it on Windows with the BPF program and wasn't able to do it. And then it was way over my head. So I took a step back to just learn the basics, which is what I just demonstrated. And I haven't gone back to trying to get this thing to work for that program again. And so potentially, yes, that's the idea, is that the way that they've built eBPF for Windows is they would be able to cross-compile some of the eBPF programs, but like, yeah, your mileage is going to be varied there. So.
This is really cool. I mean, nobody's ever even sort of taken a stab at this. So thanks a lot, James.
Cool. Yeah. Yeah. I'm working on the redirect, and I there's just as I said, there's a lot of things I'm learning from. It's been a long time since I wrote C, and so yeah. Hopefully, I'll get something working eventually here, and then I can maybe move that back into like a demonstration with kubeproxy.
Cool. So you say redirect, that's just you named that function that. You don't have to call those.
Yeah.
You can put as many functions as you want in there. And then how does the map then know that it's, how does the map load that function? How does that function get loaded again?
Yeah. So this section here is you need to define.
I'm sorry, the
this.
map doesn't do that. Yeah, the map is the stuff that gets sent to it.
Yeah, exactly. So this program here, you'll see it's called redirect. Back up here in main Go, I did attach.
You attach to that string.
Yeah, so I got the program called redirect from the ELF file. So I loaded the ELF file, I got the redirect, and I attached it. And then once it's attached, now it's going to respond to any of those events that the eBPF system.
So your user space directly
firing.
attached. Yeah, so your user space has to know the name of the program that it's attaching to.
Correct.
Yeah, okay.
And then this map is the name of the map that's in here. And you can name them differently, but I don't know if it's convention or what, but they usually have the same name as the struct of the map. So, and so, yeah, and then you just write into that map, and there's a bunch of different types of maps. I'm just using a hash map for this right now. Cool. Any other questions or? So this the source for this is I put it up on GitHub here. I could put it in chat here, or else I'll link it in the notes, but I'll post it in the chat here too. Again, it's super simple. I was trying to just learn the basics because it was quite a bit to learn for me, at least. There are some requirements as to how you set this up. Right now, the eBPF program for Windows isn't signed. It's still very early. And so they're working on getting the signatures and doing a whole security review and all those things. And so until you can do that, you have to kind of load this into a VM that doesn't have that allows unsigned drivers, which is something you have to like disable and not recommended for production or anything. And then there's a few other components that are required, but defined there. So. Cool. There's no other questions. We'll wrap it up. We're a few minutes past anyways.
This is really awesome, James. Thank you for doing this.
Yeah, I'm excited to get the redirect working. That's the blocking was interesting, but the redirect is what I'm really after.
That's really cool. Thanks, James.
All right, cool.
I guess that kind of counts as our after hours hangout.
Yeah. I'm going to go ahead and stop recording if there's nothing else.
Okay.
Going
Does
once.
anybody have anything else they want to go over? I can stay a couple minutes longer, or we can drop.
Yeah, I think I'll end the official meeting here since nobody's spoken.
Okay.
See you later.